Good morning, students. On today's lecture, I'll solve Additional Mathematics Paper 2, 4037, Variation 21 of May-June 2018. Now, the first question is given that A, B, and C are subset of the same universal set, which write each of the following statement in words. So these are given in symbols. A is not a proper subset of B. We need to write down that in words. So let's write down A is not a proper subset of B. Now, most of the students, they are confused with this sign, this one and this one. This means proper subset and this means subset. Okay, let me just write down. This is proper subset, and this is proper subset, and this is only subset. What do I mean by that? If you have A with the elements 1, 2, and then B, you have 1, 2, 3. Now A, in set A, there are all the elements that also the elements of B, but less. So we can write down A is a proper subset of B. Now, when we're writing that A is a subset of B, that means, remember that X is less than or equal to 3 means X can be less than 3 or equal to 3. This thing means that A can be having all the elements of B or less than the elements of B. So that's not proper subset. This is just a subset. So this one is proper subsets. So what it's telling you that A has less elements of B, but all the elements of A also are the elements of B. All right, I hope you understand that. Now this one, A is intersecting C, is a null set. So you can write down as it is, A intersecting C is a null set or empty set, null or empty set. This one you can say a lot of different ways. A and C are disjoint set, or you can say that A intersecting C equal to like that. You can say that A and C are mutually exclusive. So there are so many different ways you can say that. Okay, so that's one of the way, or you can write down that this way. A intersecting C is a null set or empty set. You can write down that, or you can write down that these are disjoint set. Okay, disjoint set means there are no elements in common in both of these sets. Now, write each of the following statement in set notation. So it's in the words, we have to write it this way. See that it's other way around. This one was a symbol and we had to write down in words, and these are in the words and we have to write down in set notation or symbols. Okay, there are 3 elements in set A or B or both. Whenever it was A and B, that actually means A intersecting B. When it's like that A or B or both, that means A union B. So A union B, there are 3 elements. So number of elements in A union B equal to 3. So this is done. And B, X is an element of A, but it is not an element of C. So it's in element of A, but not in C. So not in C intersecting A. So that means some elements belongs to A but not in C. So which one is that element? X. So X is an element of C prime or complement of C intersecting A. So that's that. That was question number 1. Now let's do question number 2. The variables X and Y are such that Y equal to ln 3x minus 1 for X is greater than 1 by 3, and find dy dx. Now dy dx differentiation of the exponential function is going to go 1 by 3x minus 1, and we need to differentiate chain differentiation of 3x minus 1. That's going to give us 3. So it's going to be 3x minus 1. So that's done. 2 marks. Wow, 2 marks for this. Okay, hence find the approximate change in X when Y increases from this to that. So if this is Y, this is Y, let's say this is Y1, this is Y2. Okay, so From here, it changes that. So what is delta y? Delta y equal to y2 minus y1. So that's going to be ln 1.2 plus 0.125. That's my y2. And then y1 would be ln 1.2. Okay, so that's that. So you can see that if I take the bracket of this cross out. So delta y is going to be 0.125. Okay, and when we have that, we can write down dy dx equal to delta y by delta x. We have dy dx right over here. Okay, but look at this. I don't have the value of x. But for the timing, let's put that one. 3 over 3x minus 1. And delta y, we got it, 0.125. And the question says approximate change in x. So we need to find out delta x. Okay, so delta x comes over here, and over here 0.125 times 3x minus 1 divided by 3. I need the value of x. How can I do that? Let's go to the original equation. Okay, that's y equal to ln 3x minus 1. And remember what was y? Y was this, ln 1.2. From here, it changes to this. So this was our initial y. So we can write down ln 1.2 equal to ln 3x minus 1. Ln, and everything after ln they are equal. Therefore, don't cross it out. Okay, don't cross it out. You can cross that out. 1.2 equal to 3x minus 1. If 1 comes over here, 2.2. So x is going to be 2.2 divided by 3. You cannot cancel out. Keep it as it is. Okay, sometimes keeping it as it is, we might be able to either cancel out 3 or 2.2. Okay, if it was 2.1, we could have just canceled that out and reduced into smaller fraction or another number. Okay, so keep it that way. Usually student, whenever they get that, they just divide that and they take this value 0.73. So this is approximate value when you are taking 0.73. Okay, but this is exact value. Keep that one. So what I'm going to do over here, 0.125 times 3, and see that x's value? I'm going to put x's value over here, 2.2 divided by 3. I hope you can see that this is the reason I didn't take that value. Minus 1 divided by 3. So that cancel out. So on the top, 0.125, and this is 2.2 minus 1. That's going to give me 1.2 divided by 3. If you cancel that out, it's going to be 0.4. We can multiply that, 0.125 times 0.4. Now we got 1 by 20, or it's actually 0.05. Either answer will do. Okay, so that's 2. Now let's go for question number 3. A 7-character password to be selected from 12 characters shown in the table. 1, 2, 3, 4, 4 3s are 12. Okay, each character may be used only once. So uppercase letter A, B, C, D, lowercase letter E, F, G, H, and digits are given 1, 2, 3, 4. Find the number of different passwords if there are no restriction. So there are no restriction. So it's a password. So order matter. So arrangement matter. So out of 12, I need to have 7. So P7. So that should be 12 P7. That should be a huge number, 3991680. Okay, so that's that. All right, and that starts with a digit. With a digit, I have 4 choices for digit. So you can write down 4, then times out of, say, I already have taken 1, right? One of the digits taken. Okay, from this digit, one of the digits is taken. Let's say I have taken 1. So I have 3 digits, and over here 4 lowercase, 4 uppercase. So 4 plus 4, 8, 8 plus 3, 11. Out of 11, I need to take 6 because 1 is already has taken, and order matters. So P6. So it's 4 times 11 P6. That's going to be 332640 times 4. The answer should be 1330560. Okay, so that's done. Now that contains 4 uppercase letters. So I have to have 4 uppercase letter and 3 lowercase letter. such that all uppercase letters are together and, okay, this is very important, all uppercase letters are together and all lowercase letters are together. So uppercase, I have to take, let's say, 4 uppercases, so all uppercases. So this, now there are 4 choices for uppercases, A, B, C, D. So first one, 4 choices, second one 3, then third one 2, then that, so it's 4 factorial. Okay, order is important because A, B, C, D and D, C, B, A is completely different arrangement. So there are 4, and I have to take 3 lower cases. Okay, so 1, 2, 3. So E, F, G, H. First one I have 4 choices. Second one I have 3 choices. Third one I have 2 choices. First one 4 choices. Second one 3 choices. Third one 2 choices. Okay, now this one 4P3. And this one you can write down. I hope you know that 4P4. So this 4P4 and 4P3. But think about it. I can place this one over here and this one over here instead of the 4 uppercases here, 3 lower cases over here. It can be arranged 3 lower cases here, 4 uppercases there. Okay, so it's 2 factorial. So the answer are 2. So it's going to be 4P4 times 4P3 times 2 factorial. So that's going to be 4P4. I got 24 times 4P3. That should be 24 as well. 24 times 2. So 24 times 24 times 2, that's 1152. That's the answer. Okay, now we're going to go for the next one. Question number 4. It is given that x plus 4 is a factor of this function when p of x is divided by x minus 1, the remainder is b. So that's remainder, and this one is a factor. So show that a equal to minus 23. Let's put that x equal to, say, x plus 4. So x plus 4 equal to 0. So x has to be minus 4. So I'm going to put that one minus 4 over here. Okay, minus 4. So every x over here will be exchanged by minus 4. So minus 4 to the power 3 plus 3 minus 4 square plus a, then it's going to be minus 4 minus 12. Okay, so that's going to be minus 4 minus 4 minus 4, and that equal to 0 since it's a factor. So 0 is going to be minus 64. So you can see that minus 4 to the power 3, that's minus 64 times 2. I got here minus 128, and this is going to be positive 16. 16 times 3, that's going to be plus 48 minus 4a minus 12. If I bring this minus 4 to that side, that's going to be 4a. And here minus 128 plus 48 minus 12. I got minus 92. So a is going to be minus 92 divided by 4. That's going to be minus 23. And that I was about to show. So you can write down showed or shown. Okay, so that's done. Now another part. Find the value of constant b. Now this one, I'm just going to use a different ink. It says that when this is divided by x minus 1, the remainder is b. The way I have done that, I'm going to do a little different like this over here. So x minus 1 equal to 0, x equal to 1. So when I replace that, the remainder is b. Okay, I put it this way. I just show that there are so many different ways you can do that. So this one, 2, 1 cubed plus 3, 1 square minus a is 23. We got it from there, 23. X is 1 minus 12 equal to b. So b equal to, over here is 2 plus 3 minus 23 minus 12. So it's going to be 5 minus 23 minus 12. I got negative 30. B equal to negative 30. So that's done. Okay, factorize p of x completely, and hence when you do that, hence find all the solution of p of x. Okay, so I can do a vanishing method. I have this 2x cubed plus 3x squared minus 23x minus 12. What I'm going to do, I'm going to start with that because my factor is x plus 4. All I need to do, I need to multiply this with something so that first term gets equal. So 2x squared, see that 2x cubed. So that's 2x cubed plus 8x squared. 2 4s are 8x squared. Now over here I have 3x squared. I have written 8x squared. So I have written 5x squared more. So I have to have that, and then I have to subtract 5 x squared. So I can take 5x here. Okay, if I take 5x over here, then it's gonna be minus 5x squared. Now this equals that 8x squared minus 5x squared, that's going to be 3x squared, and over here minus 5 4s are 20x. Now here I have 23 and minus 23, and over here I have minus 20, so I have written actually 3 less. So again 4 minus 3, I don't need to put x, it's minus 3. Okay, minus 3, so that's going to be minus 3x. Now this equals that, and this is going to be minus 12. So from here I can take this common, x plus 4, and then I'm ending up with 2x squared minus 5x minus 3. That looks like a middle term break. You can use the calculator for that, but I'll just do the middle term break. 2 3s are 6, so it can be written as 2x squared minus 6x minus plus x minus 3, x plus 4. I'm not going to spend that much time on this one. I hope you do understand that. 2x x minus 3 plus 1 x minus 3. So that's going to be x plus 4, then x minus 3, 2x plus 1. Okay, now it says that hence solve that. So p of x equal to 0, p of x equal to 0. So this whole thing equal to 0. Therefore, x equal to minus 1 by 2 minus 4 plus 3. So that's my final answer. Okay. Now question number 5. Okay. We have a function f defined by this, x is greater than 2.5. Okay. And find the expression of inverse function. So inverse function, we need to take that one as y equal to 1 by 2x minus 5, and I need to make x is the subject. So bring this one, transpose this one to the left hand side. So 2x minus 5, and take that one to that side, 1 by y. So what happened? 2x equal to 1 by y plus 5, and then x equal to, I can keep it that way, and then 2 gonna go here. So inverse function of x is going to be 1 by 2, then 1 by x plus 5. So that's that. Okay, I don't need to do anything. You can simplify that, but that's okay. All right, to state the domain of inverse function of x. Now this one, actually most of the time students make mistake. You look for this one, since the domain of the function of x becomes, okay, its domain becomes the range of this one becomes range of inverse function of range. Okay, domain of the function of x becomes the range of that. Now this is the domain. Okay, now this is the range. Now they are asking for the domain of this one, so I need to find out the range of this. Okay, so what would be the range of that? If you take little bit over 2.5, okay, let's say you take 2.6. Okay, so we need to concentrate on this value. Okay, now look at this. The bigger, see, we're gonna put the value of x over here. Okay, if we put, let's say 3, okay, this is 3, so 3 2s are 6, 3 2s are 6 minus 5, that's gonna be 1 by 1 equal to 1. If you put, let's say 4, so this is gonna be 8 minus 5, that's 3, 1 by 3, it's less than 1. Okay, but see that it cannot be 0 or less than 0. So the bigger the value of x, okay, the bigger, let me write down this, the bigger the value of x, okay, then this function tends to get 0. Okay, so it tends to get 0. So the range tends to get 0. So over here, the domain of inverse, this range is gonna be x is greater, domain is gonna be greater than 0. It's never gonna be 0. So this is never gonna be 0. It's greater than 0. It's 1 point. I hope you understand that. Okay. The bigger this value, compare this. Okay. You can pause the video and think for a second that the bigger of the value of x, that greater than 2.5. Now function of x becomes really close to 0, and function of x is your in a range, and domain is 2.5. So when it gets to 0, this range gets to 0. Now its domain is gonna be close to this range, or the range of the function of x is the domain of inverse function. So x is gonna be, domain is gonna be greater than 0. It's gonna go really close to 0, but then it's gonna go up. Okay. Now find the expression function square x, giving your answer in this form. So this actually means function of x, composite function. Okay, so function, and I had function 1 to x minus 5, and then it's gonna be 1. See that I'm gonna replace the value of x by this one, 1 to x minus 5, then minus 5. Okay, if I take the bracket off, 2 gonna be up there, and this is 2x minus 5. If I take this, then it's gonna be 5 2x minus 5, 2x, and this is gonna go up. So 2x minus 5, taking the bracket off, that's gonna be minus 10x minus plus 25. Okay, so it's gonna be 2x minus 5 over 27 minus 10x. Okay, so that's that. And then I can write down, it says that a, b, c, and d are integers to be found, nothing else. So if I compare that, actually, see that cx, I'm gonna write down this 2x minus 5, then minus 10x plus 27 in this format. Therefore, comparing this with this, see that this with this, so I have a equal to 2, see that a equal to 2, b equal to minus 5, c equal to minus 10, and d equal to 27. Okay, so that's my answer. They didn't ask to find out the range of values of x, or range of values of y, or domain or range of this, so that should do it. Okay, thank you for watching. In my next video, I'll cover from question number 6. Take care. Have a good day.